Hey everyone, in this video we're going to be talking about the laws of exponents, and then we're going to move on to factoring using some of these laws of exponents. So we're going to take a look at the laws first and do a few examples of simplification there, and then we're going to move on to 3 factoring examples. So at any time you could just click over here on the left side to where you want to go in the video, and the link will take you right there. So to begin, let's take a look at the laws of exponents here. Some of these have names, some of them don't, so sometimes I'll refer to these with their name. But the first law we have here is known as the product law. So if we have the product of two numbers with the same base, in this case the base here is a, they have the same base. When you multiply these two together, you're going to add the exponents. So, for example, if we had, 5 squared times 5 cubed, this would equal 5 to the 2 plus 3, which is equal to 5 to the 5th power. And you could simplify that if you would like. And if you want to see why this is true, it's easy to discover these laws on your own as well. You just need to think about what exponentiation means. Like in this case, 5 squared means 5 times 5, and 5 cubed, so we have another multiplication here, but 5 cubed means 5 times 5 times 5. So our answer, as you see, we're getting 5 fives, thus our answer is 5 to the 5th power. So this is why we add these exponents together when we have the same base, because this is essentially what's happening right here. Now the next law is the power of a power rule. So we have a to the m, and all of that is raised to the nth power. And we see that this is going to result in an answer of a to the m times n. So let's take a look at an example of why this is true. So if we take something like 5 squared, of course we know what that is, that's 25, right? And let's say we cube that. This is equal to, according to the power to a power rule, we should get 5 to the 2 times 3, which is equal to 5 to the 6. Now this law is also fairly easy to discover on your own if you just think about what the exponents mean here. Here we have 5 squared, and it's being cubed. So that means this right here is 5 squared times itself 3 times. Times 5 squared times 5 squared. And then the 5 squared here is equal to 5 times 5. And then this one here is 5 times 5, and this one here is 5 times 5. So we see we get 5 to the 6. So we're going to have that 3 times 2 to get that 6 in the power here. Now the next rule here, it's, let me see. Oh, I forgot something here, right there. Okay. So the next rule here is it's a power of a product. It's basically just an extension of the power to a power rule. If you have the product of two numbers inside of parentheses, here I have a to the m times b to the r, and that's all raised to the nth power, then you could go ahead and essentially distribute this n to the m, so we get a to the m times n, and you could distribute it to the r to get b to the r times n. Now, that doesn't work if this is an addition sign here. Okay, so you want to be very careful of the mistake. If you have a plus b, and suppose this was squared, this law does not say that you would go ahead and distribute the 2 to the a and then to the b. This is a very common mistake, so look out for this one. You want to think about this one here, like what does exponentiation mean? This would mean a plus b times a plus b, all right? And then you would have to use these foiling methods. I haven't talked about that in any videos yet, but in a future video I will. So you want to be careful of this mistake here. right? But if you have a to the m times b to the r, then if it's just separated by multiplication, you can go ahead and distribute that n to both powers like that. The next rule here is referred to as the quotient rule because what we have is a division here. So when you have the same base, right? So when you have an A and an A, but the A could represent anything. You know, like if we have 2 to the 5th power divided by 2 to the 4th power. The quotient rule says we should get 2 to the 5th minus 4, which is equal to 2 to the 1st power, right? So you're going to take the top power and you're going to go ahead and subtract the lower power here. I mean, not the lower power, but the power that's in the denominator. So in this case here, we do the base is 2, right? So we have 2 and then 5 right here, and then we subtract the bottom power, which is 4, and we get 2 to the 1st. You want to be careful of the mistake. If you have something like x to the 5th plus 4, let's say we divide this by x cubed minus 2. A common mistake is for people to want to see these two x's here and say, okay, by the quotient rule, you should get x squared. And then look at this 4 and this 2. 4 divided by 2 is negative 2, right? But unfortunately, it doesn't work as easily as that. When we have these terms separated by addition and subtraction, there's going to be a few more processes you have to apply really to get your final simplification. So this is definitely something to watch out for. You know, you can't just divide how you want like that. So now going back to the quotient rule here, you know, if we have this case, we should get 2 to the 1st power. But watch out to see if things are separated by additions or subtractions here. The final rule is just an extension of the quotient rule, and it's a mixture of the power to a power rule as well. Just like in the case when we had this power of a product, this is power of a quotient. This n could be applied to the m, so you multiply those two together, and we get a to the m times n, and then you can also multiply it by this bottom power, r. And we would obtain b to the r times n. Okay, so these are the rules, and you know you're gonna eventually memorize all of these once you do a lot of work in mathematics. You have to apply these rules all the time, so they just come naturally after a while. But these are the main rules we're gonna work with. So let's take a look at an example that's gonna apply some of these rules, or maybe just a few of these rules here. So in these two examples, I have a and b. We want to go ahead and simplify this expression, and we want to simplify this expression. So we just want to try and manipulate this to make it look neater, I guess. You know, do any computations that you can, and see the minimum amount essentially that we need to write, right? Now it also says to write the final answer using only positive exponents. So this is going to be practice with using a particular formula I discussed in an earlier video, which was if you have a to the negative n, this is equal to 1 over a to the positive n. Or if you have, let's see, if you have a to the positive n, this would equal 1 over a to the negative n. Okay, so we're going to have to do a couple manipulations with this here. You know, if we have a negative power in our denominator, we're going to be able to move it up, and we're going to change the power to positive because these two statements are equivalent. Or if we were given an expression with a negative power in the numerator already, we're going to go ahead and flip it and move it to the denominator and change the sign of the power. So we're going to be doing some flipping around using these two formulas here, so you want to keep these two in mind. So now getting to example A here, we have x to the fifth times y squared over x to the first times y to the seventh. Now let me go ahead and just rewrite this here. Now the nice thing about this problem is that there's no additions or subtractions to really worry about here. So in this particular case, we see that we have 5 x's up top and 1 x down below. So the quotient rule says that we should get, now our base is x, so we should get x to the top power minus the bottom power, which is x to the fourth, right? Now that's going to be the x's. Now we could take a look at the y's separately here too. It's going to be times. Now y to the second divided by y to the seventh, according to the quotient rule, should be y to the top power minus the bottom power. Okay. Now, what do we get? That's going to be x to the fourth times y to the negative fifth. And we need to write our answer, our final answer, using only positive exponents. We see here that we have a negative exponent, right? So if we wanted to, if we wanted to work with only positive exponents for some particular reason, the x to the fourth is fine, so we could leave that alone. But y to the negative fifth, remember, you could write that as 1 divided by y, and then instead of the negative 5, we could change it to a positive because we moved it into the denominator. And this, of course, would be equal to x to the fourth divided by y to the fifth. So that's example A. Now, in example B, we have a few more rules that we need to apply. And there's going to be a number of ways you could go about this particular problem. You could work within the parentheses first, and you see x squared divided by x and y cubed divided by y to the fourth. Maybe you could simplify those and then apply this outside power. Or it's also appropriate to apply this outside power first. And that's how I'm going to go about this problem. So nothing is separated by addition or subtractions, as you could see. So this is going to be a combination of the power of a power rule, power of a product rule. So we have a product up here and a product in the denominator as well. And it's also going to be the power of a quotient rule, where we could apply this -1 to each piece here. So since everything is joined nicely through multiplication, this -1 is going to go ahead and be multiplied by all of the powers. So this is going to turn into, now if you remember, the power of a power, x squared to the negative first would be this power times this power, so we get -2. And then the 3 times the -1, we're going to get -3. Now we have a division. And then, now this is x to the first power, right? And 1 times -1, we're going to get -1. And then 4 times -1 for the y, we'll get -4. Okay, so that's fine. Now there's a few different things you could do here too. But what I'm going to do here is I'm going to do the division. I see, okay, I have an x in the numerator and in the denominator. So the quotient rule says this would be x to the -2, and then we're going to be very careful of the sign here. It's going to be minus a -1, and then we're going to have a y here, and that power is -3, and we're going to subtract the bottom power, minus a -4, right? That's the quotient rule. It's taking the top power and minusing the bottom power, as long as you have the same base, right? Now this simplifies to x to the negative first, right? Negative 2 plus 1. And then this is negative 3 plus 4, which is positive 1. Okay. So now, lastly, I want only positive exponents. So here I have a negative 1. But what's going to happen is that's going to change into 1 over x to the first. 1 over x. And then y to the first times 1 over x is just y over x. Okay, so in these particular examples, it was a combination of all the different laws. So if you need to go take a look back at what the laws were and maybe try a few more of these examples using a book. Now, moving on, we're going to talk about factoring. So we want to be able to factor. And we're going to talk about this because we needed to know the product rule, essentially, for factoring, as well as the quotient rule. So I did an earlier video about factoring. I'll put that link in the description. And these are going to be the same types of problems. The only difference between this portion here and the earlier video is we were working with linear terms in the earlier video. So in this particular example, we're just working with higher powered terms. Now we have x to the fourth, y squared, and x to the fifth, and z squared. So we're going to have to know the laws of exponents to be able to factor something like this. So the way we factor something like this is we want to take a look at the three terms that we have here. So we have 8x to the fourth y squared times z. And then we're subtracting 6x to the fifth y z squared. And then we have a 4x cubed y cubed. So the way we factor this is essentially it's reverse distribution. You want to take a look at what these three terms have in common with each other. And you want to try to factor out the greatest common factor. Okay, so between our constant numbers, 8, 6, and 4, what's the highest number that's going to divide into each of these pieces? Well, it's only going to be 2. 2 goes into 4, 6, and 8, so we're going to go ahead and write that down. Now, we're going to go ahead and take a look at our x terms. We have x to the fourth, x to the fifth, and x cubed. Now, the piece you could take out is going to be the highest degree, it's going to be the lowest degree variable here. In this case, we have x cubed. So x cubed goes into x to the fourth, because you can multiply this by x and it goes into there. It also goes into x to the fifth, because if you multiply this by x squared, you get x to the fifth. So it's just going to be the lowest degreed term here that you're going to take out. So between x cubed, x to the fourth, and x to the fifth, what's the smallest piece that's going to go into each of those? Well, it's going to be x cubed. Now we do the same thing for the y's. We have y squared, y to the first, and y cubed. What do they all share? Well, they all have at least one y. So we write that down. And then we have a z to the first, z squared, and this one does not have a z. So do they all share at least a z? No, they don't. So we cannot write that down. So this 2x cubed y, this is our greatest common factor. So once we find that, we go ahead and open up our set of parentheses, and we want to ask ourselves, what do we have to multiply this greatest common factor by to get each of these three pieces again? All right, there's a few ways to think about it, but that's probably the easiest way to think about it. What we're actually doing is we're going through each term and we're dividing out what we're taking out here. All right, but you don't necessarily need to think about it like that. You just need to think about it as, all right, 2 times what value will give me 8? A 4. And x cubed times what will give me x to the fourth? An x. And a y times what value will give me y squared? A y. And then we have a z remaining, so we need a z here. Okay, and now this is why we needed to talk about the laws of exponents, because you needed to know that x cubed times x to the first would give you x to the fourth, and y times y would give you y squared. All right, so now we have a minus sign, so we drop that there. Then 2 times what will give me 6? We have a 3. X cubed times what will give me x to the fifth? Well, according to the product rule, we would have to multiply that by x squared. And y times what will give me y? Just the number 1, but we don't need to write that in. And then we have a z squared here. So we still need that z squared, because we don't have one out here. Next, we drop the minus sign here. Now 2 times what will give me 4? 2. You have an x cubed times what will give me an x cubed? A 1, but we don't need to write the 1 because we have the 2 here. And 2 times 1 will just give me the 2. And y times what will give me y cubed? Well, y squared. Now if you see, now this is a factored term here. Right? We broke it up into a multiplication between lesser parts. So this value here times this value in parentheses, if you were to distribute, would give us the original expression here. And that's all we're trying to do with factoring, is break an expression up into smaller parts such that when those smaller parts are multiplied together, we're going to get the original expression. So we're writing equivalent expressions. They're just different ways to see it, and they have different advantages to see it in different ways. Now, in example 2, we have the same type of deal here. We want to go ahead and look at the 3 terms and see what they have in common. So we have 14, 2, and negative 12. What number goes into all of those? Well, because we have a 2 here, it's only a 2 is going to work. And then x cubed, x to the 6, and there's no x's over here, so they don't share any x's. We could think about it being as x to the 0, right? They share 0 x's. And if you recall, x to the 0, or any number to the 0 besides 0 would be 1. Right? So you could think about it like that too. And then for y to the first, y to the fourth, and y to the fifth, they all at least have 1y, or y to the first. But you don't need to write the exponent of 1. So now 2y is our greatest common factor. So once we find that, we open up the set of parentheses. And we want to ask ourselves 2y times what will give me this expression. And we need a 14 here, so 2 times 7. We have an x cubed, that stays put. And a y times what will give me y? A 1, but we don't need it there. Oops, not closing it yet. And then we have an addition sign. And then 2 times a 1. All right, let me write it in because I don't have anything else here yet. And then we have an x to the 6. And then we have y times what will give me y to the fourth, y cubed. And then we have a minus sign here. We need a 6 here because 2 times 6 will give me the 12. And then y times y to the fourth will give me this y to the fifth. And then we close that set of parentheses. So if you were to check your answer, you could do 2y times this value. It should give me that value. And 2y times this expression here should give me this. And 2y times the 6y to the fourth, we get the negative 12y to the fifth. All right, so again, it's just writing this first expression in factored form. And now with example number 3, we're doing the same thing. We want to factor. So in this particular case, I guess we don't need the laws of exponents too much, but I just want to remind you that we could factor out binomials as well as monomials. So we have our first piece here and our second piece. You want to look at what these two pieces share, and you see that they both contain y to the fifth. Y plus 5. So we could factor out y plus 5. And remember, once you figure out the greatest common factor, you're going to open up a set of parentheses. Now, between the 7x and the 4, there is nothing in common, right? The number 7 and 4, those numbers are called relatively prime because their only shared divisor is the number 1. So we can't take anything out from there, and then we have an x here, but this term over here does not have an x. So the most we could take out is y plus 5. And now, y plus 5 times what will give me this first expression? Well, we need the 7x here. And then we drop our minus sign. And y plus 5 times what will give me the second expression? Well, we need the 4 there. And also you could think about it as this first expression, if you divide out the 7 plus 5, you get 7x. And for this second expression, if you divide out the y plus 5, you get negative 4. And if you do this multiplication, you'll see we indeed do get this expression. Although, if you know how to FOIL this, so if you know how to multiply binomials, you may get a different form. However, these two forms are still equivalent. And I'm just reminding you of this particular fact here for the next video I'm going to be talking about, which is factoring by grouping. This is a very important step in factoring by grouping. Okay, so that's laws of exponents and products and factors. I hope you enjoyed this video, and I'll see you in the next one.